Regardless of what scenario of stratospheric aerosol injection, or SAI for short, could hypothetically unfold, we'll need to be able to detect its impacts.
If SAI were ever to be deployed on a large scale, we would be able to see it using existing sensors mounted on satellites, which directly observe the composition of the stratosphere. These are the same methods we use to observe the influence of volcanic eruptions.
But humans don't live in the stratosphere, we live on the surface, which raises the question, could we detect the effects of SAI deployment on our weather or the climate in specific regions?
Because of the chaotic nature of day-to-day weather within the climate system, this may be difficult. Many regions may not feel a clear effect from an intervention for years after deployment.
Even if SAI were to work perfectly as intended to maintain or cool global temperature, some regions could experience warming due to other factors, such as naturally occurring variability in the climate. Such factors may cause an intervention to be perceived as a failure, regardless of whether it is working or not.
In the short term, after the hypothetical deployment of an intervention, it may be hard for humans to feel whether SAI is having the intended impact.
To try and identify impacts as quickly as possible, we investigate the use of machine learning models as one powerful tool to help us detect the potential effects of SAI on the surface climate. These models can quickly learn the regional patterns that represent the response to the SAI intervention. In some cases, they can provide confident detection within a year after deployment begins.
With better knowledge of the Earth system, we may be able to speed up the time we need to detect SAI impacts while improving our understanding of both climate change and the Earth system itself.